what is the general algorithm, pictorial representation, everything we studied related. Okay, there are a few problems also that may come on it, which probably we are going to see it on the later part of it. Okay, so because that may come, may not come, there's no clarity in the syllabus also related to that. Okay, but we'll do for sure, just to make sure that to be to be towards the safer side of it. So what is today's technique? Okay, what is today's thing that you are going to look for? Okay, see, under divide and conquer technique, okay, there are 4 examples that you need to study. First one being your merge sort. Second one will be your binary search. Third one will be your quick sort. Fourth one is Starson's matrix multiplication. What is all that? You're going to see later. These 4 examples you need to study. And these 4 examples, and keep this in mind, in these 4 examples, and along with divide and conquer thing, 2 questions will come for sure. 2 into 10, 20 marks. So you can easily write 1 question just by knowing all these things. Okay, just by knowing all these things, I sort of got all your what you call old question papers and all. The problem here is, if you sort of look into any of your 15 scheme syllabus, then it will be completely different. You should not be looking into it. 17 scheme syllabus is all fine to you. Okay, it is almost similar to your syllabus, but the problem there is you have only 1 question paper. Of course, 1 plus 1 more backlog, so 2 question papers. 18 scheme people, your seniors who are now in 6M, were the first people to write this subject. Okay, 18 CS 42, that's a code, right? They are the first people who are supposed to write this exam. But as you people know, when you people were in 2nd SEM, they were in 4th SEM. Did you write the exam? No. So obviously, even they would not have written the exam for it. So what does it mean? It means you are the first people who are going to write this exam. Okay, you will be the first people to write this 18 CS 42 DA exam. So how the question paper may be, how the question paper will come, will all depend on whatever the idea that you are going to get from the 17 scheme. Okay, so anyway, at the time, once we do all these things and all, for the exam probably we get to know what needs to be done and all. Before that, the important questions, everything will be giving to you. So don't have to worry about it. Okay, so let's look into this, what needs to be done here. Okay, today's session, what is the thing to be done? We are going to learn about everything related to merge sort. Okay, not today's session. It will take another 3 sessions for sure, because there's a lot of things for you to study in this. Now, what is the thing with regard to merge sort? You would have seen merge sort somewhere in 3rd SEM, right? 3rd SEM, you would have learned what is merge sort and all. We're going to look into the same old example for it now. And then along with that, there are certain extra things which you got to keep in mind. First one foremost thing is, what is the merge sort definition of it. Okay, that you're going to study, fine. Then you're going to take one example. Okay, you're going to take one example, you're going to trace the part of what is the meaning of tracing. Example tracing, just like what you did in DMS. When you took an example, you split it up, then you conquered it, then you put it in some sort of an order, that you call this as example tracing. Then you're even going to write the general algorithm for it. Okay, then there is one thing extra that is you're going to do. You're going to write an algorithm. Be careful here. This algorithm is different. This algorithm is different. You're going to write one more algorithm to do what? To merge two already sorted arrays. That's very important. Okay, already sorted array you're going to merge, which basically means you're going to get an array like this: 1, 2, 3, 4, 5, 6, 7, 8. See, these are already sorted. These are already sorted. How we are going to merge this one with this one? Okay, and form the new one, which is nothing but 1, 2, 3, 4, 5, 6, 7, 8. This is what you are going to study, and for that you have one more algorithm that you are going to study. Okay, and then at last probably you are going to study about the time complexity, because without that we are not going to end any of our DA syllabus. Okay, you are going to study the time complexity in both the ways. Okay, what is the meaning of both the ways? Both in your substitution method and of course in your the other one, which is next last class thing, which is nothing but master's theorem. You're going to learn through this. You learn all these things, then merge sort is done. You do the same thing even for quicksort, even for binary search. Why? The question is very simple, okay? The answer will be very simple like this. Any question that comes on this will come for 10 marks. Standard 10 marks question. Okay? You have to write from, say, what is it? Sometimes if you are lucky, they may ask only these two. Then you will be very, very lucky. Okay? Can easily write those things, you get 10 marks. But generally, they may go for the combination of definition, example, tracing, okay, general algorithm, and of course the time complexity, all of this. Then it will easily be a very standard 10 mark question. You should be able to sort of do all these things for everything. Okay, for everything. Again, it's more like your mathematics. It's more like you need to consider this as mathematics only. Then only the subject becomes very interesting for you to score good marks. Okay, see, your seniors, everyone have got results, so you people are the next people to get results. Okay, so hopefully your results will come. I think a little bit late because your majority of the places the valuation is still not done. Okay, that took third sem because of all the lockdowns, all those problems. Hopefully it will come. Okay, someday. Fifth sem guys, they got the results and all. Okay, yesterday I think, yesterday, day before yesterday. Now let's look into this. Okay, what are the things to be kept in mind? First one is we are talking into thing called merge sort. Now what is the things to be kept in mind here? First and foremost thing, merge sort is a classic example. Okay, very, very classic example of your divide and conquer technique. Is that correct? Very clear. Okay, it's a classic example of your divide and conquer technique. So what is this merge sort? It's a process of merging two sorted vectors into a single sorted vector. Okay, so you'll be basically having, you're basically going to divide an array or a vector or a list of elements, and then you're going to merge it into one place. Okay, you're going to merge it into one place. That's what we call it as merge sort. Any doubts in that? No, there's no any doubt in that. Okay, everyone knows that. So what we do now? What we do now is we are going to take an example. An example which any of the old question papers you're going to see, which any of your DA textbooks which you take, you will be finding that example. That example only I'm going to take, and then we are going to do the tracing part of it. This becomes very important. In the previous two, the 17 scheme people, okay, that got this for the tracing part itself for 10 marks. Now think about it. Okay, so what needs to be done here? They have given a array of elements. What are the elements? 60, 50, then go with 25, 10, 25, उसके बाद 10, then 35, 25, 35, 25, 75, 30, 75 and 30. What needs to be done here? The tracing part needs to be shown. The trace of merge sort needs to be shown. So what needs to be done? How it needs to be done? Very, very simple. First one thing is you got to think that this is unsorted. This is not at all sorted. Okay, this is not sorted. So what we are going to do is we are going to do what is known as the tracing part of it. How do you think this can be done? It can be basically done like everyone knows this. I'm not doing anything extra. Okay, just writing the same old aspect of what you know, what you already know. Okay, so let's do the tracing part of it. When I sort of do the tracing part, how you are going to get? You're going to get things like this. You're going to get what? 60, comma next 50, comma 25, and then one more probably 10. Because how many you got? 1, 2, 3, 4, 1, 2, 3, 4. So 4, 4. So what's the next thing? 35, then fast. Okay, 25, 75, then again 30. Then again the next two things, it's going to be sort of split into two parts like this. Okay, neatly you need to do. Then what's the next thing? You get something like a 60, then you got a 40, sorry 50. Then you got a 25 and a 10. Then here again two parts, right? So what is it? 35 and 25. And then next one more, you're going to get 75 and 30. Okay, two parts that are fully done. Next, again, what's the next thing? Next thing is you are going to again split this into two parts again. So this will become 60 and 50. This will become 25 and 10. This will again become 35 and this will become 25. 75, this is 30. This is all done. Okay, this is all done. Now very important part. Okay, very important for you to sort of show something. What is the thing that needs to be shown like this? Okay, I'm just going to write that. Please understand this. This becomes very important. You have split everything. That is one part of it, which is all fine. Okay. Now you need to show one important part here. What is that one important part? You need to sort of write what is each one of it. So what you call this entire part. Okay. This entire thing, you call it as a divide technique, right? This is what you are going to divide. Okay, this is the entire thing which you sort of divide, and you want to show the split of it. Okay, this entire thing is nothing but the split part is nothing but your divide part. What will be the next one? Obviously, the next one will be your merge part. Okay, the merge part, and one more thing you need to show is this is your unsorted vector, right? Unsorted array of elements. Now what's the next thing? Next thing is you need to show what is known as the merge part now. How you are going to do it. That's what is becoming very important now. Okay. Now let's do that. If I start doing that, okay, be careful here. The way I'm writing it, that becomes very important. Okay. So this and this come together and forms what 50. Don't write again 60 and 50. Okay. Don't be that stupid. You have to write it 50 and 60. Then again these two will come together and this will form 10, 25. Okay, and this will become 25, 35. These two again will come together and forms what? 30 and 75. Right? Then again, what's the next thing? Next thing is these two will come together to form the new set of elements, which is 10, 25. Be careful. 10, 25, 50, 60. Then these two will come together to form one more thing called 25, 30, then again 35, 75. Done. Now what's the next thing? The last one. The last one which you need to show and should also write few things there. Okay. So when I write like this, what is going to happen? This entire thing, when I take these two things into thing and then write, what is going to happen? You are going to get 10, 25, one more 25, okay, 30, 35, then 50, 60, 75. So 50, 60, 75. Now there is one more thing you need to write. Once you get all those things, you know it's all correct. Now you need to write this as sorted array of elements. There will be a split like this. You need to show that, and then you need to clearly say that this one is a merge part. First one is the divide technique and then is a merge part. What do you call this? What do you call this entire thing? This entire thing is known as tracing of merge sort. Okay. If you are lucky, this itself along with definition of merge sort everything, okay, will come for 10 marks. If you are not lucky, it will come for maybe 5 or 6 marks like this. Even 5 or 6 marks is also too good for this, right? I mean, even a small child can do this. Okay, so 5, 6 marks also, or if you are lucky 10 marks also, is too good for it to be written like this. Okay, simplest of things, simplest of parts. For this, what's the next thing? Okay, what's the next thing? Next thing is a general algorithm. Okay, you are going to learn about the general algorithm, or what is known as the simplest of algorithms. Now, how do you think that algorithm would be? For sort of write that algorithm, there are a few things which you got to keep in mind. Okay, so I'm going to write that algorithm. There are a few things that you got to keep in mind. Okay, please understand that. Okay, so what is it? Merge sort. What is that algorithm? I'm going to write what is known as the algorithm for my merge sort, the general algorithm of your merge sort. Okay, so if I write like that, what is going to happen? Okay, first and foremost, there are two things which you have to keep in mind. What are the two things that you're going to do this? There is something called, there are a few things that are, the terminologies you have to remember here. Okay, algorithm for what? Merge sort. Now I'm going to write that. Please understand this. I'm going to tell you what is that and all. Okay, there's nothing new and all, but few things which you got to keep in mind. Okay, merge sort for an algorithm, and what is this? A will be representing your array of elements. And then there's one more thing that you're going to get, low. What is low? Low will be representing your first element. High. What is I representing? The last element. A representing array of elements, low representing the first element, I representing your last element. Okay. Then what is my next thing? What is my purpose? You need to show that also. Okay. My purpose is to do what? To sort the elements, correct? Sort the elements in merge sort technique. That is my purpose. Now purpose is written, that my purpose is to make sure that I'm going to sort the elements in merge sort technique. What is my input? What's the next thing, right? You need to write that also. What will be my input? Array of elements. Okay. An array of elements, be careful here, unsorted elements. See, the way you write, that becomes very important. Array of unsorted elements. What is it? Unsorted elements. Okay, and then along with that you need to specify one more thing. Unsorted elements with low. What will be low? Low as the lower bound. Okay, this will be known as your lower bound, and of course I as your upper bound or higher bound. Okay, generally upper bound. So that is my input. What will be my output? My output basically will be with regard to an array A, okay, an array A which is a sorted vector, okay, a sorted array is very much a sorted array. Okay, now what's the next thing? What is the next thing to be written? Now the real algorithm needs to be written here. Okay, for that what you think I'm going to do? Okay, the same old aspect of it, nothing new. Okay, same old way of writing it. There's no new way of doing it and all. First and foremost, you need to find out whenever you got your low and high and all. If there is any low and high and all, what is the first thing that you are going to look for? You are going to look for what is known as the midpoint. Okay, so can I write that now? The first thing that you're going to look for is your midpoint. So where do you think you're going to find the midpoint of it? Okay, you're going to write the entire thing like this. First one is, one second. So the algorithm will be sort of written like this. First, if low, okay, is less than high. What's the meaning of low less than high? That needs to be understood. Okay, low less than high. When do you think low will be less than high? When you see this, low is the first value, any first value like 1. High value is some other value, okay, some bigger value, okay, some bigger value. So it's basically clearly means that it is in a way where you have to sort of divide it into two parts. Okay, you have to sort of divide it into two parts. Okay, so what I'm going to do now? Okay, based on this, I can write very easily if low is less than high. I'm going to first find out the midpoint. What is that midpoint? The midpoint will be low plus high. Full right, I'll write low plus high divided by 2. Then this is the next thing. Okay, I am going to do the merge sort repeatedly. Okay, I'm keep on going to do the merge sort. Be careful here. I'm going to do the merge sort part of it repeatedly for an array A. Okay, for an array A, right from the first element. Okay, till where? Because we need to divide it into two parts. That you need to know, right? See, if there is an array like this, we basically divide it into two parts like this. This will be representing your low. This will be representing your mid. Okay, this will be representing your high. Okay, so I need to keep on doing the merge sort right from your low, which is the first thing right here. Okay, up to where? Up to mid. Is that correct? Up to mid, I need to keep on doing it, which basically means I'm talking about this. So this will be done repeatedly. Why repeatedly? Because again this will be split again. Again it will be split again. So, okay. So this keeps on doing repeatedly. So only you can see this. It's calling that function merge sort. A low mid. Okay. Keeps on doing repeatedly. Next one. Next thing. I need to go for this one also, right? So what is that? This one need to be represented. From where? What's the next element? From the next element is up to midpoint. Low to midpoint is left one. So what's the next thing I'm going to write for the right hand side? Merge sort. Okay. For again, there's a A. Then from the next part, mid plus 1. Why plus 1? Because I need to start from the next element after mid. Okay. So mid plus 1 up to where? Up to high. Okay. Up to, keeps on up to high. Then what's the next thing? What is the next thing? I need to sort of merge all these things. Right? I need to sort of merge all those things. So what is this? This one is basically sorting the left part of it. This one is sorting the right part of it. Then sorting everything over, uske baad, you need to merge it, right? You need to merge it. So thus again, I'm going to bring what is known as a simple merge function. Okay, simple merge function to do what? To make sure that I am merging right from A, okay, around A, up from where? From low to mid to high. This basically means I'm going to start from the first place till here, from there till here. Okay, this will be sort of merging. Okay, understand this? These two are sorting it. This one is merging it. Okay, this one is with regard to merging it. Okay, of course, later part is you're just going to write and if. That's all. Algorithm is all done. Okay, the algorithm is fully done. This is all it needs to be done. You know what is merge sort. You know what is the tracing part of it. You know how to write an algorithm. Good. That's all done. Okay, that's all done. But this is not the end of it. Right? This is never an end of it. You all need to sort of look into other aspects also. Okay, what are the other aspects which you have to keep in mind here? See, if I want to write what is known as a time complexity for this, what will be basically whatever we know till now. Okay, whatever we know till now, based on that, can we write a time complexity of this? I think we can easily write a time complexity of it. Okay, how you can write a time complexity of the merge sort? It is very much clear from the algorithm, right? That the entire problem or array will be divided into two equal parts. That's very important. Two equal parts many times. Okay, if you take like that, what is going to happen? To take for a complexity and all. First one is, remember this, okay, t n by 2 for the first one, then again t n by 2 for the second one. Then of course you will be having one more called, plus 1 or cn like that. To do what? To do what is known as the merging part. Okay. So this is with regard to time complexity. Same thing only, one, dividing the left part, dividing the right part. Whatever you studied in the divide and conquer, the general divide and conquer technique, that only will come in here. Okay, so the time complexity also needs to be found out, that we are going to see at the later part of it. Okay, at the later part only we are going to do. You don't have to do it now itself. Okay, but now the next important. Okay, I told you, right, there are a few steps that to be kept in mind here. One after other you are going to write. Okay, one after other you are going to study that. Okay, So what's the next thing? Next thing is we need to study how to write an algorithm again, okay? Algorithm if the left part, the right part are basically already sorted. They are basically already sorted. So what you can do for it? Okay, what is the example that you are going to take for it, and then how you are going to write for it. That's something which you need to sort of listen to. Okay, the algorithm for it. This is a very big algorithm, not very big compared to the previous algorithm. This is big, like that you need to think. Okay, so for this we are going to take an example. Again, a very important tracing part. Okay, tracing part. I like tracing. Right, I love tracing. Okay, probably in whatever very few days what you learn C programming, you have seen me that I love tracing. Okay, especially any programming subject, anything. I want to see tracing part how it works on them. So that we are going to do that. Okay, I'm taking one example. Of course, writing an algorithm is what is very important for your exam. But before that, the tracing part becomes very important. So that the algorithm becomes understandable. Right? So let's do that. Okay, for this we are going to take an example. What example? We are going to take two arrays. The left part and the right part it will be depicting. Okay, it will be representing the left part and the right part. The left part I'm going to take it as A. The right part I'm going to take it as B. Okay, stay in the class. Okay, I know it's afternoon session, so only making it as more of a problem based things. Okay, just listen. Okay, it's 2:52, so up to 3 be in the session. Okay, so let's do this. I'm going to take this example. Okay, what is already I told you very clearly that left part and both the right part are already sorted out. Okay, so I'm going to take a things like this. They are not equal, be careful that, but they are sort of what see as they are already sorted out. Let's say 40, then this is 50. Yeah, that's correct. Then again, I'll take this as 15, 25, and probably 30. Understand this. What is one important thing that you can make out? They are already sorted. Okay, they're already sorted. You don't have to worry much. Okay, you don't have to worry much. Whatever the algorithm you saw in the previous instance, there it was not sorted. So you due to merge sort everything. That's all fine. Everyone knows that. Now they are already sorted. Now, how many elements are there, and they are not equal also. Intentionally, I'm taking the one which is not equal because if you take equal, it becomes simpler. One second, this is 40. Okay, people should not get confused. What is writing order? So this is 40. Yeah, now it's visible. See, now what is the next thing? Next thing is these two are individual arrays which are already sorted. That's all fine, but I need to put it in a place, right? I need to merge these two. So I'm going to take one more. These two are A and B. Obviously, this is C. Okay. Obviously, this one will be C. And what will be that? And how many elements it will be having? If there is 4 and 3 here, so obviously it will be having 7 here. Okay. 3, 4, 5, 6, and 7. Check 1, 2, 3, 1, 2, 3, and 1, 7. Okay, you got your 7 elements there. 7 elements, not a problem. So I've got everything here. What's my next thing? What is my next thing? See, I got my left part, I got my right part. I need to put it in C. The logic. That is very important. Okay, this is where the entire algorithm will stand by. Okay, so can I sort of represent this entire thing? The first element here. Okay, the first element here as I. The first element here as J. I and J. So what I do? Okay, what I do? That's very important, right? The first what I do is that's the first thing that is very important. I'm going to compare. Be careful here. Look into the words. I'm going to compare the first element of A with the first element of B. First element of A is sort of compared with the first element of B. What is the other way of writing it? What's the other way of saying it? I is compared with J. Okay. Then what is the next thing I do? Whichever is a smaller element. Okay, whichever is a smaller element, that element will be copied onto C. Is that correct? Yes. That element will be copied onto your C. Can I do that now? Okay, I'm just going to represent this. Be careful here, or else I'll just take it out. I'll just show you how it works and all. Okay. Now be careful. The first element is represented by I. Why I need I, J and all? Because to write it in a general form, you need to know. Okay, you can't always take 10, 20, 40, 50, 15, 25, 30 every time to talk about things, right? You need to talk it in general terms. So only we take I and J. So what I do, what is the thing I told you? I'm going to compare the first element of A with the second element of, first element of B. There's a parda here, okay? I think there's a line here, just like how the line we have here. So I'm going to compare the first element here, which is 10, along with your first element, which is 15 here. What is going to do? What I'm going to do? Okay, one second. Little bit more I'll take. What I'm going to do is I'm going to compare 10 is less than 15. Very much clear, very clear. So what I'm going to do? 10, whatever the 10 that is there is getting copied. Okay, is getting copied to your C. See all these things, please understand. Whatever I'm doing here now, I'm going to put it in form of an algorithm later. Which is a very, very important algorithm, because whatever the algorithm you saw just previously, that was the simplest of algorithm. Okay, everyone can understand, everyone knows that. Okay, just for 1-2 steps only I'll do. Anyway, you are going to continue tomorrow's class. Okay, 1-2 steps only I'll do, because you have to get an idea of what I'm trying to do here. Okay, that what is a smaller element here? 10. That will be copied right here. What's the next thing? 10 is already done. Okay, 10 is already done. So what is algorithm I write? Whichever element is getting copied. Can I write like that in very simple words? Whichever the element is getting copied, you need to sort of increment that, correct? You need to increment that particular array. You need to increment, otherwise it will be keep on comparing 10 with 15 only every time. That needs to be sort of incremented. So what I'm doing it, I'm sort of going to do what is known as incrementation. If I do like that, okay, if I do like that, what is going to happen now? Again, this is very important tracing, so keep that in mind. Okay, keep that in mind. So if I do that, again you need to write that. People may be thinking how many times we need to write and all. You need to write, can't help. Okay, again it may come for 10 marks, so you have to write. Okay, so 20, 40 and 50. Now where is I? Now where is I? I is here, because the element that was copied to C was from this array. So it is incremented. So the array is, I is here. Okay. Now that will be copied into the one more thing, right? What was the one more thing that you're going to copy? Do you have to compare again with 50, or do you have to compare with 25? 15 only. 15 didn't do anything, right? It didn't go anywhere. It is staying there only. Okay. 15 is a good person. He's staying there only. Only 10 went, out. So you need to compare with what? You need to compare with 15 only. This will be J. So what are you going to do? You're going to compare this with this. Again, here also you need to write one more. So only I told you it's very important, because it comes for a 10-mark question, and also it's a big one. 10 is already there. You don't have to do anything. Now 20 is getting compared with 15. 20 and 15. Okay. So what needs to be done? Which is smaller? Okay. Which one is smaller? 20 is very much greater than your 15, right? It's very much greater than your 15. Okay. I can easily write like this. So which will be getting copied? Whichever is the smaller will be getting copied. So 15 will be getting copied to your C. So what will this become? This will become 15. And that needs to be, wherever the array that was there, that needs to be incremented. So this needs to be incremented now. Here before it was, this needs to be incremented. Okay. Now J will not be there. It will be going into 25 in the next 10. Like this, you need to keep on doing for everything.